Alright, welcome everybody. So today I'm going to finish up acids and bases with you and talk to you a little bit about some of the things that are on the IB exam. That's what I'm really going to focus on today. One more thing I want to talk to you about with titrations though is the idea that you can actually titrate an acid that has more than one hydrogen in it. And it's a polyprotic acid, an acid with many hydrogens. And so here they're showing you a titration with phosphorus acid, H3PO3. And when we look at this phosphorus acid, what we see is that there's the three H's to begin with, and then you actually can remove that first H using base, and you will get H2PO3 and have your first equivalence point. And if you keep adding base to this is happening at a relatively low pH, you could actually get a second H removed until you reach where you only have HPO3 2- and get your second equivalence point, and that's much higher. So you can actually have, a titration where you're removing multiple H's and you kind of get these stacked curves. So that's kind of cool to look at. They don't really ask many questions on this, but I just thought I would throw it in there in case it comes up. Now we've already kind of discussed what happens when an acid and a base, when they titrate each other, you produce a salt. And this is just sort of some general rules for you, if you have a strong acid and a strong base, you will yield a neutral salt. If you have a salt that's made from a strong acid and a weak base, you'll produce an acidic salt. And so, for example, if I were to titrate this weak base here, NH4OH, and this strong acid, HCl, I would produce a salt that would have NH4 plus and Cl minus. And this is what you should have learned in honors chemistry or Regents chemistry is, hey, like strong acid, weak base will yield an acidic salt. But understanding the chemistry behind it, why this actually happens, has to do with a hydrolysis reaction. And what happens is when we produce this salt, NH4Cl, we have NH4 ions, and we have Cl minus ions. And while both those ions are floating around in solution, the NH4 plus, that came from the weak base NH3. That means that NH4 is acting as a weak acid. It's the conjugate acid and it's a weak acid. And so what we can see from this is that the NH4 will then react with the water, and that's sort of highlighted here by this reaction. The NH4, the hydronium, will react with the water. It'll form NH3, but it also produces H3O+. So this is a hydrolysis reaction. A quick way to know it is, strong acid, weak base, yield an acidic salt. But the chemistry behind it is that the ions that are produced in the salt, only the acidic or the positive ion reacts with the water. You could also have a situation where you have a strong base and a weak acid, and we see this one really most commonly. So here we have the salt yielded from strong base, NaOH, and a weak acid, acetic acid. And so when we have that one there, we have the salt NaCH3COO, and it's only the acetate. Okay, it's only the acetate ion that is reacting with the water, and we see that down here, and it's producing hydroxide ion. So, it's important to know this. We did this with titrations, and we talked about calculating the pH, but sometimes they ask a qualitative question, and this is helpful in doing that. So on to some of the IB things that you're required to know. One of them has to do with the energy changes in neutralization. And this first neutralization I show you here is a strong acid plus a strong base. And in general, the neutralization is around 57 or negative 57 kilojoules. It gives off heat. And then we have this other situation here where I show you a strong acid and a weak base. And you can see that the delta H is slightly less. Here we have a weak acid and a strong base. And again, the neutralization is slightly less than the 57. And here we have a weak acid and a weak base. And that one has the lowest of all of the neutralizations. So now why does this actually happen? Well, the thing is that when these are neutralizing each other, if we were to have the HCl and the NaOH, in that case, we would have them existing already as ions, H plus and OH minus, and these would just be able to come together. So we didn't spend any money or any energy to actually pull them apart. So we didn't spend any energy to pull them apart. And so because of that, we don't have a lower or a more positive, I should say, delta H. When we have something down here where both of these are weak, we have to first put energy in to ionize them. So that takes away some of the energy. How much energy did it take to ionize these so that they'll react? Well, it took about 7 kilojoules. Okay, there are some reactions that they ask about, and these you kind of know about, but we'll go over them. So one of them is an acid with metal, and so you could have your acid HA plus your metal M, and you will produce Ma, which will be a salt, and hydrogen gas. And so that would, depending on how this was balanced and what the ions were, it would be dependent on what coefficients you need to use. So for example, if I did HCl plus zinc, we would get ZnCl2 due to the charges in H2, and we would need to have 2 of the zinc there to balance it out. So this is a metal plus an acid. Now again, certain metals, they don't react with acids. Things like gold, silver, mercury, copper, they're resistant to reaction with acids. So that's, something that has to do more with oxidation reduction, and we covered that earlier in the year in Chapter 3 and Chapter 4. I will mention it again when we get to the redox chapter as well. So here's another reaction, a metal carbonate, something like calcium carbonate, and reacting with acid. And what you'll do is, if we break this down, you'll actually produce H2CO3 and CaCl2. So you'll actually produce H2CO3 and CaCl2, but then the H2CO3, it's unstable. So it will actually make H2O and CO2. And if we add these together, these cross out, and you're left with calcium carbonate plus HCl yields H2O plus CO2 plus CaCl2. Something that you can try doing would be to write a net ionic for this, because the AP exam, they want to see that you write this using net ionic equations. So give that a try and show me it in class, and I can tell you if you're right or not. All right, the last thing I wanted to cover with you is acid deposition. And this is just defined as where you have these acid-forming pollutants, which I'll discuss in a second, and they get deposited on the Earth's surface. And so one of the things is knowing where the actual pollutants come from. And so the general places where they come from are through some kind of industrial process. And this has happened through, the economic growth and people modernizing, and going into an industrial era where they are now, producing these pollutants that they weren't producing before. One of this main pollutants is acid rain. And this is coming mainly from these gaseous pollutants that are non-metal oxides, and they are these 3 in particular. So the nitrogen monoxide and nitrogen dioxide, those will react with water as follows, and they will produce both nitric acid and nitrous acid. You can also take this nitrous acid, this HNO2 here, and you can react it with oxygen in the air, and you can produce nitric acid as well. And so these are really toxic chemicals that are occurring. They acidify the water, and if you've ever seen that sort of brown, hazy, smoke that's, in Los Angeles, it's in a lot of mainland Chinese cities. This is due to these pollutants, these gaseous pollutants reacting with the water and with the oxygen in the air. Sulfur is one of the other pollutants that's found in coal. And so the sulfur can combine with oxygen in the air when it combusts from the coal. That's why all these, coal pro-coal people are talking about clean coal, you know, burning clean coal. Dirty coal would have a lot of sulfur in it, and that sulfur would form sulfur dioxide. And sometimes when you burn coal, you get that sort of rotten egg smell that comes from this. Well, this SO2 that forms upon the combustion of coal will react with water and form some sulfurous acid. But also, you could get some of that SO2 combining with the oxygen, just like NO combines with oxygen to form NO2. We get SO2 plus oxygen, we get SO3. That SO3 can combine with water and form sulfuric acid. So what are people trying to do about this? You know, like how can you help? Well, one thing that can be done is to actually combine the SO2 upon combustion with something like calcium oxide, and that will actually sequester it. That will, you know, pull it out before it starts to react with the water, and you will get calcium sulfite instead of sulfuric or sulfurous acid. So this stuff they ask about on the IB exam. I would know these facts and know these equations. So hope that was helpful. Thanks so much for watching.